Today we're going to start looking at systems of linear inequalities. So let's get started. Let's do a quick review of systems of linear equations. So if we're asked to solve this following system, and we have two linear equations. Now if these two lines are not parallel, meaning the lines have a different slope, so here we have a slope of -1 in the first equation, and a slope of 1 in the second equation. If we graph these lines on this two-dimensional plane, so let's graph y equal to -x plus 3, and then y equal to x minus 1, these two lines that are not parallel to each other are going to cross at one location. And where they cross, this is their point of intersection. And this is the one point, the one ordered pair that they have in common. So this point, in this case the ordered pair 2, 1, is the solution for the system. Now let's look at a system of linear inequalities. So we're asked to solve the following system. We have y greater than or equal to -x plus 3 and y less than x minus 1. So we have two linear inequalities. So let's start by graphing each of these inequalities. So with y greater than or equal to -x plus 3, we're going to graph the equation y equal to -x plus 3 to find this boundary line. And this will be a solid line because we have greater than or equal to. And then we need to pick a point on each side to test to see which side of the boundary we shade. And then we shade that side of the line. So here we have graphed y greater than or equal to -x plus 3. So this shaded region plus the solid line itself that represents the boundary line for this inequality, these are all of the solutions, all of the ordered pairs, that when we plug those ordered pairs, that x and y value, into this inequality, we will get a true statement. Looking at the second inequality, we have y less than x minus 1. We'll start by graphing the line y equal to x minus 1. This will be a dashed line because it's y less than, as opposed to y less than or equal to. And then we'll select a point on either side of this line to determine which side to shade. So for this inequality, this blue shaded region, but not this dashed boundary line, represents all of the ordered pairs that when plugged into the second inequality will result in a true statement. So the solution for this system of linear inequalities is going to be the region of intersection. So instead of a point where these two lines intersect, there's going to be a region where these two linear inequalities intersect. And it is this region that is the solution for this system of inequalities. So let's test a point in this region. Now I'll go ahead and pick this point here, which is the ordered pair 4, 2. So let's test a point in that region. We're going to plug it into each of these inequalities. So we'll have 2 greater than or equal to -4 plus 3. This is 2 greater than or equal to -1. And that's a true statement. And then checking the other inequality, we'll have 2 less than 4 minus 1. And then this is 2 less than 3. And that's also a true statement. So every point in this region is a solution to this system of inequalities. Now how about that point where those two boundary lines intercept? Is that a solution? Well, let's see if the ordered pair 2, 1 results in a true statement when we plug it into both inequalities. So for the first inequality, we'll have 1 greater than or equal to -2 plus 3. This gives us 1 greater than or equal to 1. Well, that's a true statement. For the second inequality, we have 1 less than 2 minus 1. So this is 1 less than 1, and that is not a true statement. So this point where these two boundary lines cross, where they intersect, is not a solution. No point on this blue dashed line is a solution. However, all these points on the red line that have an x value greater than 2, they are a solution. Let's take a look at some vocabulary. And this should be a nice review from when we looked at systems of linear equations. Again, a system is a collection of simultaneous relations. In this case, our relations are going to be inequalities. So we had the inequalities y greater than or equal to negative x plus 3 and y less than x minus 1. Systems are conjunctions. A conjunction is a mathematical sentence that joins two or more mathematical statements using the word and. So for systems of linear inequalities, we're joining inequalities using the word and. So the solution must be true for both of these inequalities. And then the solution set for a system, well, that's all the ordered pairs, so all the points or values that satisfy all the relations, all the inequalities in that system simultaneously. Now with non-parallel equations, that was a point. But for non-parallel linear inequalities, our solution is going to be a region. But before we actually find that region, let's see how we can determine whether a given ordered pair is a solution to that system of inequalities. So to do this, we're going to plug this ordered pair into each of these inequalities to see if we get a true statement. So we have the inequality y less than 3x minus 5. So where there's a y, we replace it with a negative 2. Less than, this is 3 times 4 minus 5. The left side cannot be simplified down any further. It's simply the number negative 2. Then we have less than, and then simplifying down this right side, we have 3 times 4, that's 12 minus 5. So this is negative 2 less than 7. And negative 2 is less than 7, so that's a true statement. And then with this second inequality, we have y less than or equal to 1/2 x plus 2. So this is negative 2 less than or equal to 1/2 times 4 plus 2. This is negative 2 less than or equal to 2 plus 2. And negative 2 less than or equal to 4. And that's also a true statement. So yes, this ordered pair is a solution to this system of inequalities. So we were able to find this answer without graphing these inequalities by simply plugging in this ordered pair into both inequalities. But let's take a look at this graph. So with this red dashed line, we have y less than 3x minus 5. And then this red area is shaded. And then y less than or equal to 1/2 x plus 2 is this blue solid line. And then we can see the area shaded in blue. And then we have this overlap of red and blue making purple. And so this is the solution set for this system of linear inequalities. And the point 4, negative 2, is located within this region. Every point in this purple region is a solution to this system. Let's try one more. Determine whether the given ordered pair, the ordered pair 2, 3, is a solution of the system of inequalities. So we have two linear inequalities. And we want to see if this ordered pair is a solution to both of them. So let's plug them in. So we have y greater than or equal to negative 2x plus 3. So where there's a y, we'll replace it with a 3 greater than or equal to negative 2. And then where there's an x, we'll replace it with a 2. So that's negative 2 times 2 plus 3. And then simplifying down this right side, negative 2 times 2 is negative 4 plus 3. So this is 3 greater than or equal to negative 1. That's a true statement. And then y less than x plus 1. So y is 3 less than 2 plus 1. We have 3 less than 3. Well, 3 is not less than 3. 3 is 3. So this is not true. So this ordered pair is not a solution of the system of inequalities. Let's take a look at this graph. So in red, we have y greater than or equal to negative 2x plus 3. So we have all this area shaded. And our boundary line is solid because it's greater than or equal to. Y less than x plus 1 is graphed in blue. This is a dashed boundary line because it's y less than. And then we have a region shaded in blue. The solution to the system, it is this purple region once again. We have red and blue making purple, where these two inequalities overlap each other. These are all the points, all the solutions they have in common. Now looking at this ordered pair 2, 3. So here we have 2, 3. So this point is on the dashed line itself. And because this is a less than and not a less than or equal to, the points on this blue dashed line are not included in the solution. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these two problems. So for both of these examples, we're testing whether an ordered pair is a solution for the system. And we do this by plugging the ordered pair into both linear inequalities that make up the system. And then simplifying down both sides to see if we get a true statement. So with this first system, we have y greater than negative 2/3 x plus 4. Plugging in the ordered pair, x value of 0, y value of 4. We end up with 4 greater than 4. That's not true. 4 is not greater than 4. Repeating the process with the second inequality, we end up with 4 less than 4. Again, that is also not a true statement. Since both of these have to be true at the same time, we could have stopped as soon as we saw that that first one was false. And if you're in a rush, maybe you stop once you get that first false statement. But it never hurts to do the other inequality, and we happen to get false with that one as well. Either way, the answer to this problem is no. That ordered pair is not a solution. Looking at this graphically, you may have noticed with these two inequalities that they have the same y-intercept, the y-intercept of 4. So the point 0, 4 is where both of these boundary lines cross the y-axis. But because these are dashed lines, the points that are on these lines are not going to be included in the solution. And then with the second system, both of these are written in standard form instead of slope-intercept form, but we're going to solve it in the same way. Wherever there's an x, we're going to replace it with a negative 2. And wherever there's a y, we're going to substitute that value of 8. Simplifying down both sides of the inequality, we end up with negative 12 less than or equal to negative 3. That's a true statement. And then with the second inequality, we end up with 6 less than or equal to 6. So in this case, equality was allowed, and that is also a true statement. So yes, negative 2, 8 is a solution to this system. And looking at this graphically, so in red, we have 2x minus y less than or equal to negative 3. And in blue, we have x plus y less than or equal to 6. Both of these boundary lines are solid, so the points on the line themselves could be a part of the solution. So the ordered pair negative 2, 8. So this point is on the boundary line for x plus y less than or equal to 6. But because equality is included, it's less than or equal to, the points that are on this line can be a part of the solution as long as it overlaps with the other inequality. So this entire region that's purple is the solution set. Drop any questions you have in the comments. Continue practicing working with systems of linear inequalities, and I'll see you in the next video.